everyone. We've got lots to do in this video. It might even be two, so let's just dive right in. In our last video, we talked about what the heck is a least squares regression line. And today we're going to talk about how we actually calculate it. Now, depending on what kind of information you are given, is going to depend on how you calculate the line. If you're given just the raw data itself, that's one way to do it. Another way to do it is if you're given some different information. So, you were given a formula sheet, right? A brightly colored formula sheet. And on that formula sheet, we have different pieces, how we find slope and y-intercept. Now, sometimes we say y hat equals a plus bx. Sometimes we say y hat equals b sub 0 plus b1, or b sub 1x. And one way we can do it, if we're given our correlation coefficient r, and then the standard deviations of our x and y values, we can calculate slope. And then using that, and then the mean of our x and y values, we can then find y-intercept. If you want to know how these formulas came to be, you can look at page 172. So we're going to look at an example together right now. We want to find the equation of the least squares regression line. So the number of miles in thousands for 11 used Hondas have a mean of 50.5 and a standard deviation of 19.3. The advertised prices had a mean of that and a standard deviation of that. The correlation for these variables is r equals negative 0.874, which makes sense, right? The more miles it has on it, the cheaper it's going to be. Find the equation of the least squares regression line. So, they've given me not the raw data, but just some pieces of information. The means and standard deviations of my explanatory and my response variable, and also my correlation coefficient. If I look at my formula sheet, okay, this guy right here, the fourth one down, is just the general equation for the line of best fit, my least squares regression line. I'm going to ignore the slope formula directly beneath it, okay, but I am going to look at this y-intercept formula here, and then two down from that, I'm going to look at that slope formula as well. So those are the two formulas I'm going to use to calculate my line of best fit, the equation of my least squares regression line. Okay? So to start with, let's find the slope. We can call it just b. If you want to call it b sub 1, either one is fine. So the formula from our sheet, from our formula sheet, is you take r times the standard deviation of your y's divided by the standard deviation of your x's. So all we have to do here is plug and chug. My r was negative 0.874. Standard deviation of the y's. Okay, so I guess we need to define which one was y and which one was x. So which one is our explanatory? Well, miles would explain the price. So miles is going to be my x, and the price is going to be my y. So I've got my price standard deviation in my numerator, 18.99. My standard deviation of my miles in my denominator, 19.3. Plug that into your calculator. You get a slope of approximately negative 86.0. You just plug that in your calculator. Now, I need to use that number to calculate my y-intercept. Because if I look up here, there it is. Here's how I find my y-intercept, okay? So I can call it b sub 0, or I could call it a. Either one will work. So I take the mean of my y's minus my slope times the mean of my x's. So the mean of my y's was 14,425 minus this number I just found, so negative 86, times the mean of those x's, which was 50.5. Okay? So now I just plug in, see what I get. Where'd that go? Sorry, technical difficulties. And I get a y-intercept of 18,768. So then I want to find the equation. All right. So here's my y-intercept. Here's my slope. So y hat is equal to, always start with your y-intercept, 18,768 minus 86.0x. All right. Define our variables, right? X is the number of miles in thousands. Y hat is my predicted advertised price. Okay? Now, what if you're actually given the raw data, the actual. So if you're given the actual numbers and we want to find the equation, we're going to use our calculator. You're going to enter your data into your list 1 and your list 2. Now, when you're trying to find the correlation coefficient R, it doesn't matter where you put X and Y. It could go either one. It does matter for the line of best fit, for the least squares regression line. It will give you different equations. So be careful to put X in list 1 and Y in list 2. All right. You can make a scatter plot, and to look at it that way, then you can graph it as well. So this data right here is representing McDonald's beef sandwiches for 9 different McDonald's beef sandwiches. And we want to calculate the equation for the least squares regression line using technology. Make sure you define your variables. So step 1, put the data into your lists. So I've entered my data into list 1 and list 2. Next step is I'm going to make a scatter plot. All right, so refresh our minds how we do that. So I'm going to go up to second, stat plot. And right now mine is off, so I need to turn it on. Let's turn this light off. That's too dark. That's too bright. All right, we got it. So I'm going to go here, and I'm going to make sure it's turned on. Now there's lots of different types of graphs. I want the very first one. That's a scatter plot. And it has my X's in list 1 and my Y's in list 2. Great. So I'm going to quit out of that. All right. The next thing I'm going to do is I'm going to follow my instructions up here. Go to Stat, Calc, and then number 8. Number 8. So Stat, Calc. Number 8 from me is Lin Reg. And notice how it says A plus BX. You could do number 4, but then it tells you that A is slope and B is y-intercept. We want A to be the y-intercept and B to be the slope. Now, it has my X's in list 1, my Y's in list 2. Don't worry about frequency lists, but there is an option to store it. All right? So say I want to actually take this and store it somewhere. I need to type in the number Y1. The way I get there is I go to, that's how I do it. So I go to Stat, Calc, number 8. And then from here, I'm going to press vars. Let's see if you can see it. Press vars. All right. And then I scroll over to y vars, and it says function. I'm going to press enter. And it gives me all these different functions. And I'm going to click y1. All that's going to do, y'all, is put the equation into y1 for me, so I don't have to manually type it in. Okay. So now I calculate. Voila. There's my equation for my least squares regression line. So y hat equals negative 40.2 plus 1.7128x. All right, I need to find my variables. So x in this case is my carbs in grams. Y hat is my predicted fat in grams. So if you want to see what this looks like, if I go to the y equals, look, my equation is there. Log doesn't need to be there. And then if I go to graph it, now if I just hit regular old graph, I'm not going to see anything. This is why we have to go to zoom and hit option 9, because we're in stats class, so we're going to choose zoom stat. And lo and behold, my scatter plot with the line on top of it. Okay? So now we want to interpret slope and y-intercept in the context, as well as calculate and interpret the residual for a Big Mac with 45 grams of carbs and 29 grams of fat. All right? So what I want you to do now, do those two on your own, right? We talked about those in the last video. So take some time, interpret slope and y-intercept in the context, and then calculate and interpret the residual for this particular Big Mac. Okay, we've talked about the line of best fit, the least squares regression line. Now I'm going to talk to you about this thing called a residual plot. Residual plot is another type of scatter plot. Okay? It is a scatter plot of the explanatory variable, our x's, versus our residuals. So not against the response, but against the residual. So we use this for two reasons, right? The first reason is that it is used to determine how well the regression line fits the data. We shouldn't actually use R, right? It can be misleading to use R. Even if you have a strong correlation, you might not actually have linear data, all right? And I'll show you an example of that here in a little bit. Something kind of cool, the mean of the residuals of the least squares of the line is always going to be 0. So here's a visual example. Here's my scatter plot, and here's the least squares regression line. This right here on the right, this is the residual plot. Notice how the x-axis is still the same, but my y-axis is now my residuals. Now, why is there a 0 line here? Remember, residual is the difference between the actual value of y and the predicted value of y. Okay? Now, how would you interpret such a thing? Well, the residual magnifies the deviations, so it makes it easier to see unusual observations. So two ways to kind of look at it, right? The residual should show no obvious pattern in the original data if there's a linear relationship, right? A valid residual plot should kind of look like the night sky, approximately equal amounts of positive and negative. Residuals should also be really relatively small in size, but again, look at the context there to see what makes the most sense. So I'm going to show you some bad residual plots so you know what I'm talking about. Why are these residual plots bad? Well, there's an uneven distribution between positives and negatives. Here there's too many negatives compared to positive. Here there's too many positive compared to negatives. Why are these ones bad? There's a clear pattern here. We should not see a pattern, whether a linear pattern, a U-shaped pattern, etc. Here's another example, bad graphs. It starts very wide, there's a big variance here, and then it has less variability. Here is small variability, and then the variability starts to increase. So you should see a truly random pattern, if at all possible. So if you want to calculate and actually use and create a residual plot, you're going to need to have all your residuals. So this is the data that you just did. So this should be in our calculators.